So let us look at the first condition of parallelity. So let us say that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represent two parallel lines. That means both the lines making this equation have same slopes, right? So let the slopes of the lines be m comma m. Now we know that if m1 and m2 are the slopes which make up this pair, m1 plus m2 is equal to minus 2h by b, m1 m2 is equal to a by b. Now if the two slopes are equal, let us assume both to be m's. So 2m is equal to minus 2h by b. So m is equal to minus 2h minus h by b. And m1 into m2 becomes m into m. M square is equal to a by b. And substitute m from this equation in this equation. So m square is h square by b square is equal to a by b. So h square has to be equal to ab. If the both slopes of lines are equal, then h square has to be equal to ab. That's the first part. And once h square is equal to ab, if the lines are real, they have to be parallel. Next, if the lines have to be real, then delta should also be equal to 0. So apart from this, if delta is also equal to 0, then they represent parallel lines. So if delta is equal to 0, so if you expand this determinant, we get this condition: a times bc minus f square minus h times hc minus gf plus g times hf minus bg. So if you expand this, you get this. H square is already equal to ab. So abc and abc will get cancelled out. Next, if you take this, so this becomes af square plus bg square minus 2fg h is root ab is equal to 0. So if you multiply the whole equation with a minus, so this is equal to 0. So if you observe this, this is nothing but root a times f minus root b times g whole square is equal to 0. So what is this whole square? af square plus bg square minus 2fg root a root b. So something whole square is equal to 0 implies something has to be 0. So f root a has to be equal to g root b. By squaring, you get af square is equal to bg square. So if af square is equal to bg square, then this represents a pair of lines, real pair of lines. And if h square is equal to ab, they represent two lines with same slope. Hence they become parallel. So these two conditions ensure that the lines are parallel to each other. Next, if these lines represent a pair of perpendicular lines, then simply the condition is m1 m2 has to be equal to minus 1. But m1 m2 is equal to a by b has to be equal to minus 1. This implies a plus b is equal to 0. So if a plus b is equal to 0, this equation represents a pair of perpendicular lines. And apart from this, if delta is also equal to 0, they represent a real pair of lines. And a plus b is equal to 0 ensures that the lines are perpendicular to each other. So these are the two conditions which need to be valid for the lines of this equation to be perpendicular to each other. Next, if these pair of lines have to represent the lines which are coincident, that means the same equations, exact same equations, what has to be satisfied? What is the condition that needs to be satisfied? So for this, we go to the derivation regarding factorization of this equation. So we have already done this initially. So if you consider this as a quadratic in x, x will be equal to minus of this plus minus root of this by 2a. Now, if this equation has to represent a pair of coincident lines, then the condition is simply that all these expressions have to be equal to 0. So I should not get any plus minus some number. So if you have plus minus some expression, with plus you get a different expression, with minus you get another expression, which means two different lines. So if you want coincident lines, that means this whole term has to be exactly equal to 0. That means h square minus ab has to be equal to 0 and gh has to be equal to af and g square has to be equal to ac. So if h square minus ab is equal to 0, gh minus af has to be equal to 0, g square minus ac has to be equal to 0. So h square is equal to ab, g square is equal to ac, and if you simplify this condition, if you square it on both sides, you get g square h square is equal to a square f square and h square is equal to ab. So g square ab is equal to a square f square. So 1a will get cancelled. So this implies af square is equal to g square b and g square is equal to ac. So af square is equal to acb. A is getting cancelled. So f square is turning out to be equal to bc. So if h square is equal to ab, if h square is equal to ab, g square is equal to ac and f square is equal to bc, then the lines are coincident. They are not just parallel, they are exactly the same equations. They are coincident lines. Next, let us look at the derivation for the distance between parallel lines. So suppose that this equation represents two parallel lines, and we have seen that the conditions that need to be satisfied for two lines to be parallel is h square is equal to ab and af square is equal to bg square. So these are the two conditions which need to be satisfied. Now, if they represent a pair of parallel lines, let us assume that lines be y equal to mx plus c1 and y is equal to mx plus c2. So let us say that these are the two lines which make up this equation. Now, what is the pair of lines corresponding to these two equations? So y minus mx minus c1, y minus mx minus c2 is equal to 0. So this product represents the pair of lines. So if you multiply this, you get this expression: y square minus 2mxy plus m square x square minus something into x plus something into y plus something is equal to 0. Now this equation and this equation have to be same because both are made up of these lines. So the ratio of coefficients have to be same. So y square coefficient 1 by y square coefficient is b. xy coefficient is minus 2m, xy coefficient is 2h. So in this way, all the ratios of coefficients have to be same. So from this, you can get c1 plus c2 by equating this and this. c1 plus c2 is minus 2f by b and c1 c2 is c by b. And what is the distance between the parallel lines? Difference between the constants by root of a square plus b square. Because if I can find this value, this will be the perpendicular distance between the pair of lines. So from these equations, I know c1 plus c2 and c1 c2. So from these two, can I find c1 minus c2? Yes. c1 minus c2 is nothing but root of c1 plus c2 whole square minus 4c1 c2. So you got this equation that is equal to 2 times root of f square minus bc by b. So c1 minus c2 is this. So once you substitute c1 minus c2 and m square in this equation, you get the formula for distance between the parallels. So this is equal to 2 root f square minus bc divided by b into root of 1 plus m square. It is root of 1 plus, what is m square? M square by a is equal to 1 by b. So m square is equal to a by b. So if you simplify this, you get 2 root f square minus bc. By the denominator also you get b times a plus b. So this is the formula for the distance between the pair of parallels. 2 root f square minus bc by b times a plus b. And we already know that f square is equal to bg square by a. bg square by a. So if you substitute f square is equal to bg square by a and do some basic simplifications, you get that is also equal to root g square minus ac by a times a plus b. So you just need to substitute f square is equal to b by a times g square and do 2 to 3 steps. You'll end up with this expression. So try to remember these expressions if you want to do sums fast.